circuit which is used as the tuner and filter in our radio system and TV system. This LCR is used at both ends of the telecommunication system, at the transmission end as well as the receiving end. At the transmission end, while processing the signal, processing is modulation followed by amplification into a specific frequency. During this processing, some unwanted frequencies are generated, and this signal should, before being sent to antenna for transmission, these unwanted frequencies should get filtered out. To get it filtered out, you have to pass this AC signal to LCR, where it filters out all unwanted frequencies and permit only what frequency we supposed to send it through antenna. Once it reaches the antenna, that AC signal, AC current, all the information has been modulated and processed into one particular frequency of AC cycle, AC current becomes electromagnetic radiations at the antenna of transmission. These electromagnetic radiations are radio waves which will spread into space and will be available all over the surface of the earth. At the receiving end, the antenna will intercept with radio frequencies or radio waves. The radio waves available are a mixture of frequencies, not one frequency, because there are different broadcast stations. Each broadcast station will send their information through one particular frequency which is assigned to them. These different frequencies which are available, when they interact with the antenna, they will become again electromagnetic radiations change into electrical signals. These electrical signals are only AC cycle only, AC signal. Because of different frequencies, we get AC cycle or AC voltage of different frequencies, a mixture of frequencies. But to access only one frequency, to access only one broadcast, these AC signals must pass through the LCR circuit, where it filters out all the frequencies and allow only one frequency of our interest, one frequency or one broadcast station which you are able to access it. So that is what the LCR is functioning as: filter as well as tuning, selection of the broadcast. To understand the basic function of this LCR, you have to go through the theoretical background of this LCR circuit. We need to find out a proper mathematical approach to find the solution to the problem. This is the mathematical approach which is the best one to find the solution to the problem. Here the LCR circuit diagram is given. The components are connected in series and the equation is given for LCR circuit. This equation is the impedance of LCR. What is impedance of LCR? Impedance of LCR is the electrical resistance the LCR will offer to the flow of current, that is called impedance. The impedance is the resultant of all the resistances offered by three components. The resistances are R by resistor, Xc by capacitor, XL by the inductor, given by this mathematical equation. This is the resultant of all the resistances, and the graphical representation in terms of vector form, it can be represented as like this in a plane. Since the same diagram were used to represent the voltages of different components, that is VL, VR, VC. Since the current passing through remains same, current flowing through the component remains same, so we can represent this also in terms of the resistances like this. Replace voltage by resistance, you get a graphical or representation like this. Now look at this equation. This X is called as capacitive reactance, resistance offered by the capacitor. It is called as here inductive reactance, resistance offered by the inductor. And these are defined, recall the previous one, these are defined by this equation. XL is equal to omega L and omega is equal to 2 pi f. 2 pi f L. Xc is equal to 1 by omega c, 1 by 2 pi f c. What is this omega? Omega is called as angular frequency. Angular frequency, AC cycle, whether it is voltage or current, as frequency. What is the angular frequency? Angular frequency is number of rotations produced in 1 second in the AC oscillator which generates AC cycle. Number of rotations per second. It is related to this equation 2 pi f, where f is called as linear frequency. What is meant by linear frequency? Linear frequency is number of waves like this, number of cycles like this. This is AC cycle, which may be voltage or current. Number of cycles produced in 1 second. It is called as linear frequency. Number wise, that omega say. Number of rotations per second, number of cycles per second. One rotation produces one cycle of AC, linear AC, like this. Since one rotation is equal to 2 pi radians, one cycle of AC equals 2 pi radians. So we can differ by only 2 pi into F like this. So what is F? Linear frequency. F is called as linear frequency of AC cycle in LCR. This AC cycle in telecommunication, we are converting this AC current into electromagnetic radiation and electromagnetic radiation to AC current. So both of them are similar. AC is like electromagnetic radiations. So this frequency of current AC source flowing through LCR is related to these resistances and this resistance. How they are related? We can clearly understand this only when you draw the graph between X and F. This is an experimental graph. Experimentally, it is experimented on these components. Experimentally, we have measured these values of Xc at different values of F. And experimentally, we measured values of XL of this component at different frequencies and draw the graph between them. We get this graphical representation. This is for Xc, this is for XL. This Xc says that in equation like this is inversely proportional to frequency, linear frequency, and of course there is capacitance of the capacitor. Inversely means Xc decreases with increase of F like this, but not in straight line, it is in the form of curve like this. That is the graph. What is the graph for XL? XL is directly proportional to F. XL is directly proportional to F. So it is linearly related. There must be a linear increase of XL with increase of F. So XL increases, the resistance by the inductor increases linearly with increase of frequency. Here, resistance by the capacitor decreases with increase of frequency. Graphical representation. If you do so the graphs for this, you have to represent the graph for resistance as well. If you do so, it gives this graphical curve for R. See that it is a straight line parallel to F. It means resistance of the resistor remains constant even though frequency varies. It means resistance of the resistor not depends on the frequency of the current, frequency of the AC cycle passing through it. It is a straight line like this. In this graph, we can understand this is on the left hand side, all the values of Xc which are greater than the values of XL up to this point. On the right hand side, all the values of XL greater than all the values of Xc. This is the portions we are dividing this. This is the resistance offered by the individual components. What would be the resistance, impedance, resistance offered by the entire circuit containing all the components? That is impedance. Is there impedance changes with frequency? Yeah, because this is function of frequency, this must be a function of frequency. So we can also do the experiment on the LCR by measuring the impedance at different frequencies of AC. Different frequencies of AC, we get a graph and draw the graph between them. We get a graphical graph like this for variation of Z with frequency. Look at this. This is again a different portions, like left hand side, right hand side. How does the resistance or the impedance of LCR vary with frequency? There are two different ways. First, impedance decreases with increase of frequency, reaches the minimum. Then, impedance increases to increase, further increase in frequency. That is the variation of impedance. So now in this we have two graphs. This is a graph like this, this is a graph like this. This graph is a resultant of this portion. This graph is a resultant of this portion. Meet at this point. Let us understand this point. What is this point? At this point, XC is equal to XL. At this point or this point, XC is equal to XL. If XC equals XL, then what would be the value of Z? That we can understand by using this equation. That is, when you put XC equals XL, the second term becomes 0. Z equals square root of R square. Z equals R. Finally, Z equals R. What is meant by Z equals R? At this point, impedance of the circuit is equal to resistance of the resistor. It means the circuit exactly behaves like pure resistive circuit in spite of functioning of all the components. That is the behavior at this condition. At this condition, the frequency corresponds to that. That is, frequency corresponds to this point. This point is value of x exactly equals to value of L. That is called as frequency, it is called as resonant frequency. Resonant frequency. This resonant frequency is the point where resistance offered by the LCR is the least minimum possible resistance the LCR can offer. If that is the case, what would be the current? Current in the LCR should be maximum. Where there is a minimum electrical resistance, current flow becomes maximum. That we understood in terms of current also. In the form of current, look at this. One more experimental graph, one more experiment we can do. Since Z is a function of frequency, high should also be a function of frequency, because Ohm's law, I is equal to V by Z. For a AC voltage, for a certain AC voltage, these two are variables. Look at that. I is a function of Z. I is a function of Z. Z is a function of frequency. If Z is a function of frequency, I is a function of frequency. By experiment we can understand using the same LCR. Experimentally we can measure current in the LCR at different frequencies and draw the graph. We get a graph like this. Why is this a graph like this? The reason here, minimum resistance, maximum current. Minimum resistance, the relationship says that here inverse current and resistance, current and impedance are inversely related. Minimum becomes maximum for this. So exactly the graph is inverted like this. So inversion of this is this. Here this becomes a peak of this maximum current. Shows that where there is a minimum resistance, the LCO can exhibit minimum impedance and allows maximum current. It means maximum current flows through the circuit. If the maximum current flows through the circuit, that AC, what maximum current, what AC cycle, what AC signal, the AC signal of F0. What is AC signal of F0? AC signal of this F0 is resonant frequency. Only the AC current of this F0 pass through a circuit without any difficulty, without any restriction. It can easily pass through which current? The AC current of this frequency. What about AC current of other frequencies? Other frequencies are restricted because current flow is maximum only for this. So other frequency, any other frequencies, AC signal of any other frequency are getting restricted, are getting filtered out, not passing through this LCR. So those frequencies are these frequencies away from this. That is the reason the AC LCR circuit acts as a very good filter for all other frequencies and only allow only one frequency, the filtering, the least concept. So with this we shall wind up for a time and we shall carry to the next part. Thank you.